Hi everyone. So let me show you how to create porous nanoparticle. Here you can see a porous nanoparticle. So we have porous nanoparticles as examples in many areas of research. For example, porous silica. So I have created a porous nanoparticle here, and yeah, this is how it looks. You can control the pore size, the distribution, everything. And if you simply give a Google search, porous nanoparticle, you can see very nice examples. So we will learn how to create this in Blender. Okay, so we'll be using geometry nodes for that. So here you can see a similar example. Here you can see the pore size is small, same example. And in many cases, there will be something distributed inside those pores. So we will learn that as well in part 2 of the same tutorial. So let's learn. And you can consider this as, a beginning towards a series of tutorials on geometry nodes, which is a very powerful tool in Blender. So without further delay, let me start the tutorial. Here, just to give you an idea, so we use geometry nodes, don't get confused. I'll explain everything in detail. You can see everything can be controlled, like how the pore size are distributed. See, so while I move this slider, you can see the pore size is changing, and I can change the size to make cross section, for example. See. So we'll learn everything one by one. You can adjust its size. Yeah. So let's start. Let me delete everything. So create a new project and make sure that you have add a cube. I'll switch to material preview mode for now. And let's move this lamp out of the way for now. Go to geometry node editor. Here in this drop down menu, you will find geometry node editor. Click on that and you will find a side window. Close that and click on new to add a new geometry node, and zoom in using scroll wheel like this, and press the scroll wheel so that you can pan the screen like that. And if you click and drag, you can move these nodes. So the idea of geometry nodes, we use these kind of small nodes to control all the properties of the 3D object. So we have so much of control, and we can create advanced 3D objects which are not possible through other way, the normal 3D modeling. So yeah, and it is very stable. You could even create very complicated structures using geometry nodes. So I'll explain one by one. This tutorial might take more time. The goal is to make everything as simple as possible. Because many researchers were complaining that geometry nodes takes a lot of time to understand, but it does, but I will make as simple as possible. It works with basic logic. Okay, so press Shift A to open new, add new object menu. Press Shift A and you will get this menu, and I will type inside the search box volume, and you will see a few options. And you can see first one, volume cube. Click on that and you will find a node like this. Simply drop anywhere you want and connect this output of the volume to geometry input. I have switched to viewport shading to make everything easy as possible, and then we will go to material preview mode and render preview mode. Click on this output and click on this geometry node input so that they will be connected. Don't worry about this for now. Now look at the cube. It looks like a volume. So the idea is there is something known as volume. We will convert that into a mesh, a 3D object. A volume doesn't have any surface or anything. We will control the volume with something, and then we will convert that into a mesh, a 3D object. That is the idea. So let's move this here. The next step is to connect a texture. Using a texture, we can control the distribution of this volume. That is the idea. Press Shift A again, go to texture. You will find many textures. We will start with Voronoi texture. Click on Voronoi. you can see this gives you a node which has few options. So the idea of texture is, if you simply type Voronoi texture, you can see it has a pattern. Each and every texture has its own pattern. See, this pattern gives you pores, like, you know, this kind of pore distribution, like circular distribution. That is what we are going to use. Other textures will have their own representation. You can simply search. So I'll connect this distance, left click on this output and drag and drop on the input of the volume. See, now what just happened, you can see there is some kind of change happened in the volume cube. This is after connecting texture. This is before. You can see this looks smooth. After connecting, you can see there is some pattern. Now we will convert this into a 3D object. Then it will look like as if it has a porous structure inside. Okay. Now let's do that. Press Shift A. You can see volume, or you can directly go to search and type volume. There is a node, very useful node, which is known as volume to mesh. Click on that and drop it on this line, or you can drop it anywhere and drag and drop on this line, and the lines will be connected. Okay. Now look at the cube. It has formed a cube with some structures. Now we have created a porous cube. Now we will adjust the pore size distribution. For that, we will add a control slider, using which we can control the pore distribution. Press Shift A, type inside search RAMP color ramp and drop it here and connect this between Voronoi texture and volume cube. Okay, drop it there. So we are passing Voronoi texture to volume cube and we are controlling the texture using this color ramp. So move this slider. See, look at that. How cool is it? When you move the slider, the properties of basically the size distribution of Voronoi texture is changing. There is a scale distribution, but it is limited. You cannot get this kind of distribution using only scale. So that's why we are using color ramp. So if you move this here, see. So I'll keep it somewhere like this for now. And we have created a porous cube. Now we will make it smooth. You can see the surface is not so smooth. So at the end of all these nodes, we will add a smooth node. Press Shift A again, type inside search smooth. There you can see set shade smooth. Click on that and drop it at the end. See, now the surface is smooth. Okay. Now next option. So you have already created a porous cube. Next is creating porous sphere. Unfortunately, we don't have volume sphere yet, but we have to get a sphere from cube. How do you do that? There is a method. Let me show you. So the goal behind using a node known as Boolean, mesh Boolean is, so if you have a cube like this and have a sphere, you can add a Boolean operation on this, which means if you keep the sphere and cube together like this at single location, if you delete the rest of the region from the cube using a sphere, you will get a sphere, right? Basically what is happening, if you keep a cube like this, sorry, a sphere like this and a cube like this, union operation will give you a joined surface like this. If you add intersect operation, you will get the region which are intersecting, which will look like this. And there is difference. Difference means if you apply difference using sphere, sphere will be deleted from cube. So you will get something like this region. So that is the idea of Boolean operation. So don't forget that we have Boolean operation in modifiers as well. So what I am going to do, add a icosphere. Okay, Shift A, type ICO, you can see icosphere, drag and drop it inside. Now we need Boolean operation. So what we are going to do, we are adding a icosphere inside. We have a cube, we have added an icosphere, and then we will do an intersect operation, which means we will get this region. We are basically deleting the rest of this region so that we will end up with this sphere. Okay. Now add mesh Boolean node and add it here. Okay. Now this output is giving us this cube. So I'll drop it here. And we have icosphere, connect icosphere also to Boolean operation. So we need to change this operation to intersect. Make sure that both of them are connected. Now look at that. We have an icosphere which is forming this pore structure. Now increase subdivision here so that icosphere will get smooth and we will end up with a sphere like this. I hope the logic you have got. You have to try and learn. Okay, so far we have created a porous silica nanoparticle, for example, or a porous sphere. Okay, so let me duplicate it. When you duplicate an object, you need to duplicate its geometry node as well if you want to make some changes. Otherwise, for example, if I change some values here, it will affect both. So I'll go back, Control Z, and click on this option so that geometry node setup on this object also will get duplicated. So now I can adjust properties here. See, now we have created a porous cube and a porous sphere. So in the next tutorial, in the next part of this tutorial, we will add objects inside. Okay, so yeah, so to add more on this, for example, you want to reduce the size of the spheres. What you do, you start with Voronoi. So there is scale, adjust the scale. For example, if I change this to 1, you can see the scale of the pore is increasing. If I change that to 10, see the scale of the pore is decreasing. Okay, so that's how it goes. You can try changing all these values, and you can also change this slider to make the pore size even bigger. Okay, see you in the next part. All right, we have created porous sphere, and let's fill objects inside. So we have seen in the beginning, in the nanoparticle, we could fill some other objects. It could be, polymers, it could be some other nanoparticles, whatever you are filling the nanoparticle with, you can use the same approach. Okay, so let's learn that. Go back to Blender. By the way, I will add link to all these project files in the description. So to begin with, we have this node sequence. There is something known as distribute points. So press Shift, type inside search distribute. You can see distribute points on faces. So click on that and drop it here. What it does, it will add points on the faces of the object like this. Imaginary points, right? On all the faces of the object. Even in the interior, all the face will have points. Then what we will do, we will add objects on all those points. That's the basic logic. So this node, you can see it has as a mesh input, points output. So if you give any mesh to this node, it will give you points as output. So we need to distribute points on the entire object, right? So make sure that you have selected the object, distribute points on faces and drop it here. And the final output of mesh boolean you can connect to distribute on points input, and you have points. So now there is something known as type instances. Instance on points, drop it here. So when we distribute objects on all those points, there can be several applications. On those points you could do many other things. You could grow something, you could delete something. So in this case we want to add objects on those points. Whenever you want to add objects on points, you can use instance on points node. This is similar to particle system. So this gives you a lot of opportunities, even much more potential is there compared to particle system. So connect this points output to points input of instance on points, and then this output will give you all the objects added on those points, right? So now we need to join all the points from the output with this object. For that we will add join geometry. I know it can be confusing, but follow with me and do everything as I say and you will get the logic, okay? So now mesh boolean, basically the particle that we have created, this sphere, is going straight to the output. Instead we will take the sphere and we will join all the distributed points together, and then we will connect that to output. So disconnect this and connect to join geometry. Join geometry is, the basic idea is you can join multiple geometries, okay? So instances gives you objects, and connect that to here and connect this to here. Now no points are there. Why? Because we have only created points, and we have assigned all those points to be used with an object. Now we need to use an object. Just like in particle system, when you have particle system, there is something known as a render. In render we use instance object, right? Render as object. Similarly, we need to choose an object that to be used as a particle. So I'll delete this particle system, okay? So I'll simply add again Shift A icosphere. So if you have spheres on all those points, you add spheres. You could add cylinders, whatever you want. So mesh, connect that to instance. See, now you have spheres on all those points, but the size is very high. Reduce the size of this icosphere, 0.03. Now look at that. You have spheres on all those points. You can increase subdivisions to make these spheres smooth. See, this is 1, 2, 3. I'll keep it 3. Don't increase a lot because Blender will take a lot of memory space and it can potentially even crash. So switch to material preview mode. Let's add some colors. Go to materials and create a new material and change the color of the material to something, and add a new material again. Click on plus, click on new, change the base color to something else. Maybe I'll keep it yellowish, increase the brightness. Now we have two materials. Now we need to add those two materials on this object. Whenever you use geometry nodes, you need to add materials also inside the geometry node network. You cannot add directly from here. So press Shift A, click in search, type set. There is a node known as set material. So we have two components here, right? So first, mesh boolean output, which gives you the particle itself, and then you have all these tiny spheres. So we need two materials. So add set material first for the output from mesh boolean, which goes to the particle. Once you added, click inside the material and choose the material that you have created. So let me choose a material. I have a few other materials in the same project. See, the sphere looks like this. Now maybe I can change that to yellow. Okay. Now let's add material for instances. Can you guess where the set material node will be for these tiny spheres? We need to check where the output is coming for, which represent all those spheres. Instance on points. We have created duplicates of all these spheres on the faces of all the nanoparticle using instance on points. So which is giving you output. So here we need to add set material node. You could add a set material node again, or you can simply duplicate it. Select this and press Shift D and move the mouse and drop it here. See, it got connected. Now simply change the material. First cross the first material and click inside and choose the next option. See, now you have created something like this. Once you have created, you can change everything. For example, you need to increase the size of the small spheres. Where you have used this tiny icosphere. If you increase the value here, see, it gets bigger. If you want to increase its number, what you do, there is something known as density, right? If you reduce the density, see, number got reduced. By the way, the spheres are even inside the pores. How cool is that? Okay, now I'll reduce the size a little bit and increase the density, and I'll duplicate this, Shift D, and duplicate the geometry node also. And here you can adjust this max value in volume cube to show its cross section. See, now you have a cross section of that object. You can see everything inside. So if you want to increase the pore size, you adjust the scale in. See, that's how you do it. This is not possible through normal material modeling methods. So I hope you learned. If you have any questions or any doubts, let me know in the comments. See you in the next tutorial.